Okay, in this video, we are going to be looking at how to create a simple system on chip with our Xilinx FPGA board. So we're going to start by creating a new project. Decide where we're going to save it. I have it as system on chip example number 1. And we'll hit next. We're going to do an RTL project, so we'll leave that selected. In this example, we're going to be using items on the board, so we'll not need to add any files. We'll select our board, the RD S7, and then we'll hit finish. Now, this example, we're only going to use items that are built onto the board. I'll have other examples to show how we add our own custom hardware. So what we're going to do first thing is to create the CPU. It's kind of like our microcontroller. It's called microblades. So we're going to go down to this item here, IP integrator. We're going to select create a block design. We can hit OK. All right, we're going to hit to add a new IP. And we're going to search for micro, and we'll see a micro blaze pops up. We're going to hit OK. Now this will be our CPU that we'll be using. Now we're going to add some elements to it. We're going to go down to the side that says board, because we're going to be using items from our board. We're going to use the clock coming from our board, so we'll click it and drag it over. For right now, just hit OK. We'll do other steps pretty soon. We're going to go down to where it says USB UART. This is our USB serial communication, so we can print items to the screen. We can move that over. Hit OK. And we're going to use the general purpose input-output. We're going to use the 4 LEDs. On the files that we have, you'll get a build error if you use the dip switches, so we're not going to use those right now. We're going to use push buttons. So we'll drag and drop that over. Later, I will look and show you how we can put in those dip switches in later examples. So you can zoom in a little bit to see items that are on the board. These will become important later on, the order on which we add these in. So we see that LEDs are on GPIO, and then GPIO2 will have our push buttons. That's going to be important later. All right. We need to connect all these blocks together. We're going to have the system do it for us. First thing we're going to do is click the Run Block Automation. Here we have a chance of selecting how much memory we want on our CPU. Choose between the 64 kilobit or the 128. You can decide which you want to use. Then we're going to do this Run Connection Automation. And we're going to want to connect all of our devices. So we're going to hit the checkbox to select the 4 out of 4. All right, so we have it all connected. We want to organize our drawing a little bit. So we're going to go on this little circle arrow that says regenerate the layout. So it lays it out a little bit nicer for us. We're going to go down. So let's zoom in a little bit so you can see the names. We're going to go down to this clocking wizard. We're going to select it and double click. We're going to go over to output clocks. We're going to scroll down. And we're going to set that it's active low. We're going to hit OK. Once we set that it's active low, we see that we don't longer have a reset connection coming in. To reconnect it, we run the run connector again, and then our reset will be connected up. Okay, we can run this checkbox here that says validate design, make sure that we have no errors so far. And that is successful. Next thing we're going to do is go back to sources, select our design, right click, and then we're going to select the create HDL wrapper. And we're going to let the software manage the wrapper and update for us. Okay, once the wrapper is generated, we're going to go through our items of synthesis, implementation, and then I'll come back and restart the video after this has finished. Now that we are creating fairly large designs, it will take some time for your synthesis and implementation to work. So just be aware of that. All right, so I have done run synthesis, run implementation, and generate bit stream. So all of those were successful. The next item is going to be, we'll need to package everything up to send to the software development piece. We're going to go File, Export, Export Hardware. You want to make sure the Include Bitstream is checked. Once that is done, go ahead and hit OK. Next step we're going to do is go to File, Launch SDK. We'll want to leave all of these as local to the project. We're going to hit OK. And now another piece of software is going to open up, which allows us to write C code in. So it's importing all of our files. All right, what we'll do is we're going to go to a new application project. Make sure that you select that it's C. We're going to have it be hello world, and we're going to hit finish. Okay, under sources, we'll have hello world.c. This is where we'll edit our files. We will need two other includes. One is going to be include x parameters .h. That is found under our test board specific package under the microblaze include. So if we look at x parameters, what's going to be important for us towards the bottom, it'll define addresses for our GPIO. These are going to be the addresses we're going to use in order to write to our LEDs and read our push buttons. So we'll need that file. The other include we're going to need is going to be xGPIO_L. This will allow us to use two macro functions so we can write and read from our GPIO. All right, I'm going to pause the video here, write some code, and once I'm done, we'll come back and we'll see how to download to the board.